Hello students, today I am going to start class 10th chemistry and the name of the chapter is acids, bases, salts. In the last 6 sessions we already completed this chapter, so in this session I am going to discuss the exercise questions of the chapter. So let's start with the first question of the chapter, that is, first read the question. The first question from your exercise: you have been provided with three test tubes. One of them contains distilled water and other two contains an acid solution and basic solution respectively. If you are given only red litmus paper, how will you identify content of each test tube? So in this question, if three test tubes are given, out of that three test tubes, one test tube is filled with or having distilled water, second test tube is having acidic solution, and one more test tube having basic solution. If you have red litmus paper only, then how you are going to identify which solution is acid and which solution is base and which one is the neutral solution? You already know the properties of acids, bases, right? So with the help of these properties we can easily identify the solution with the help of the litmus paper. Now see the answer of the first question, that is, if the color of red litmus paper get changed from blue, then it is base, and if there is no color change, then it is either acidic or neutral. So in the acids, the litmus paper always turns from blue color to red color, whereas in base solutions the litmus paper turns from red color to blue color. So if the color of the red litmus paper get changes to blue, then it is base. If there is no color change, then it is either acidic or neutral, because in acidic also the red litmus paper shows the same color, or in neutral there will be no changes will be observed. We are not going to observe any changes in the neutral solution. The litmus paper color is remains same in neutral solution. Thus basic solution can be easily identified. Once we identify the basic solution, with the help of that basic solution we can easily identify the remaining two solutions. Let us mark the three test tubes as A, B, C. A drop of the solution in A is put on the red litmus paper. Same is repeat with the solution B and C. If either of them changes color to blue, then it is basic solution. Therefore, out of 3, 1 is eliminated, right? Out of remaining 2, any one can be either acidic solution or neutral solution. Now a drop of basic solution is mixed with a drop of each of the remaining two solutions separately, and then the nature of the drops of mixture is checked. If the color of red litmus turns to blue, then the second solution is neutral, and if there is no changes in color, then the second solution is acidic. Is this because acidic and basic solutions neutralizes each other, hence we can distinguish between them the three types of the solutions. So this is the answer of the first question. So what happens here, we're considering or we're taking three test tubes and mark it as a ABC. A drop of the solution A is put on the red litmus paper. Same is repeated with the solution B and C. If either of them changes to blue, then it is basic. Therefore, out of the three, one is eliminated. Remaining we are having two solutions. Anyone can be at whether out of these two solutions, at least one solution should be either acidic or neutral. Now a drop of the basic solution is mixed with a each drop of the remaining two solutions separately, and then add the nature of the drop of the mixtures is checked. If the color of the red litmus paper turns to blue, then the second solution is neutral, and if there is no change in the color, then the second solution is becomes acidic. So this is because acidic and basic solution neutralizes each other, hence we can easily differentiate the three types of the solutions. Okay, let's see the next question, that is, why should curd and sour substances not be kept in brass and copper vessels? So why we cannot keep the curd and sour substances in brass and copper substances or copper containers? The main intention the main intention is to avoid the spoiling of the substances or to avoid the spoiling of the foods. See here what happens. Curd and other sour substances contains acid. Therefore, when they are kept in brass and copper vessels, the metal reacts with the acid to liberate hydrogen gas. Whenever the metal will be react with the acid, it liberates the hydrogen gas. So once it releases once it liberates the hydrogen gas, it is harmful product, therefore the food will be get spoiled. That's why we cannot keep the curd and sour substances in the brass and copper vessels. Okay, see the next question. Which gas is usually liberate when acid react with a metal? Illustrate with an example. How will you test for the presence of this gas? In the previous slide we already know that whenever the acid is react with metal, it always forms a salt, along with the hydrogen gas will be liberated. So hydrogen gas is usually liberated when acid reacts with a metal. So how we can prove or how we can show the hydrogen gas will be liberated when the acid is react with the metals? For that we need to take few pieces of zinc granules and add 5 ml of diluted H2SO4. What I have to take first? Zinc granules and add 5 ml of H2SO4, shake it and pass the gas produced into soap solution. The bubbles of the soap solution are formed. These soap bubbles contains hydrogen gas, and the reaction, this is the most important reaction we are observing when the zinc granules are reacted with H2SO4. So take zinc granules and add 5 ml of diluted H2SO4. So by adding these two, we'll get the bubbles. That bubbles will indicate the hydrogen gas, liberation of the hydrogen gas. See the reaction when zinc granules is added with the H2SO4, it will form zinc sulfide. We are getting two different products here. In that, zinc sulfide is a salt and hydrogen is a liberated gas. We can test the evolved hydrogen gas by its burning with a pop sound. Pop sounds when the candle is brought near to the soap bubbles. Here in this image you are observing by taking some of the zinc granules, some part of the zinc granules. For that zinc granules we are adding the diluted H2SO4. So bubbles are formed in the test tube. Once we passed the liberated hydrogen gas with the help of the delivery tube in soap bubbles or soap solution. In the soap solution we are observing the hydrogen gas bubbles are get liberated. With the help of the candle we can easily identify the liberation of hydrogen gas. So this is the process. With the help of this process we can easily identify the liberation of hydrogen gas. So whenever the metal react with acid, it will form a liberation of hydrogen gas along with the salt. Let's see the next question. Metal compound A reacts with a diluted hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced equation for the reaction if one of the compound formed is calcium chloride. So for this question you need to write just a reaction. So when calcium carbonate CaCO3 react with the HCl, what it forms? Calcium chloride CaCl2 along with the carbon dioxide and water as the three major products. So these things were already discussed in the previous classes. Let's see the next question. Why do HCl, HNO3, etc. show acidic characters in aqueous solution, while solutions of compounds like alcohol and glucose do not show acidic characters? The dissociation of HCl and HNO3, hydrochloric acid and nitric acid, to form hydrogen ions always occurs in the presence of water. Hydrogen ions combine with the water form hydronium ions. Hydronium ions means H3O plus. The reaction is as follows. When hydrochloric acid HCl is dissolved in water, it dissociates in water, it will get decomposed into hydrogen ion and chlorine ion, and this hydrogen ion again combined with the water and it forms a hydronium ions. Hydronium ions are nothing but a H3O plus. Although aqueous solutions of glucose and alcohol contains hydrogen, these cannot dissociate in water to form hydrogen ions. Hence they do not show acidic characters. Let's see the next question. Why does an aqueous solution of an acid conduct electricity? Why the acidic solutions will consider as a good conductors of electricity? Acids dissociate in aqueous solution to form ions. These ions are responsible for conduction of electricity. So whenever the acidic substances are dissolved in water, it releases the hydrogen plus ions. That hydrogen plus ions will easily catches the electricity, or with the help of that hydrogen ions the electricity will be passes. That's why we are going to be consider the acidic solutions are the good conductors of electricity. Let's see the next question. Why does dry HCl gas not changes the color of the dry litmus paper? Color of the litmus paper is changed by the hydrogen ion. Dry HCl does not contain hydrogen ion. It is only in the aqueous solution that an acid dissociate to give ions, since in this case neither HCl is an aqueous form nor the litmus paper is wet. Therefore, the color of the litmus paper does not changes. It means at least one of the compound, whether HCl should be in the form of aqueous solution or the litmus should be in the form of liquid solution, or the litmus paper should be wetted in the form of wetted. So what happened here, we are taking both HCl and litmus paper are dried. If we are taking two dried components or two dry substances, it doesn't have any hydrogen ions. Once the compound or substances having hydrogen ion, then only the color of the substances will be changes. Okay, so see the next question. Next question is, while diluting an acid, why is it recommended that the acid should be added to water and not water to acids? Read the question once again. While diluting an acid, why it is recommended that the acids should be added to water and not water to acids? Since the process of dissolving an acid in water is exothermic, is exothermic means it releases the heat, right? So it is always recommended that acid should be added to water. Acid should be added to water. If it is done the other way, then it is possible that because of the large amount of the heat generated, the mixture splashes out and causes burn. So that's why we need to add must and should. Acid should be added to water, so it doesn't generate large amount of heat. Okay, so see the next question. How is the concentration of hydronium ion H3O plus hydronium ion? How is the concentration of hydronium ion affected when a solution of acid is diluted? When an acid is diluted, the concentration of hydronium ion per unit volume decreases. This means that the strength of the acid decreases. Let's see the next question. How is the concentration of hydroxide ion or hydroxyl ion affected when excess base is dissolved in the solution of sodium hydroxide? See the answer. The concentration of hydroxide ion would be increases when excess base is dissolved in the solution of sodium hydroxide. See the next question. You have two solutions A and B. The pH of the solution A is 6. The pH of solution A is 6 and the pH of solution B is 8. Which solution has more hydrogen ion concentration? Which of this is acidic and which one of its base? So we already learned in the previous classes the acidic solution. All the acidic solutions are having the pH value always less than 7. If the pH value is more than 7, and that substances we are going to be considered as a bases. If pH value of any solution is 7, then that solution is neutral. See here, a pH value of less than 7 indicates an acidic solution. So solution A is obviously here acidic solution, while greater than 7 is indicate that basic solution. Therefore, the solution with pH is 6 is acidic and has more hydrogen ions concentration than the solution of pH 8, which is basic. What happens when the acidic substances is dissolved in the water? It releases the maximum hydrogen ions. When basic solution is dissolved in water, it releases the hydroxide ions. That's why the solution A has pH value 6. It means it will be releases the maximum hydrogen ions and it is a more hydrogen ion concentration when we are compared with the second solution, that is solution B, of its pH value is 8. So if its pH value is 8 means it's a basic solution or basic substance. Okay, let's see the next question. What effect does the concentration of H plus ions have on the nature of the solution? Concentration of hydrogen ions can have varied effect on nature of the solution. With an increase in hydrogen ions concentration, the solution becomes more acidic, while decreasing of hydrogen ions causes an increase in the basicity of the solution. It means in any solution, if maximum hydrogen ions are having, means that type of the solutions we are going to be considered as a concentrated acidic solutions. If the number of hydrogen ions is decreases, obviously the strength of the acidic solution will be decreases. If hydrogen ions will be decreases means the solution will be get converted from acidic solution to basic solution. What happens in acidic solution? The hydrogen gas will be or hydrogen ions will be liberated, but in basic solution where observing very less amount of hydrogen ions, but the basic solution will releases the hydroxide ions. That's why H plus ions causes in increasing in the basicity of the solutions. Let's see the next question. Does basic solution also have H plus ions? If yes, then why are these basic? Yes, basic solution also have hydrogen ions. However, their concentration is less as compared to the concentration of hydroxide ions that makes the solution basic. In both acidic and basic solutions, we are going to observe the hydrogen ions, but in acidic solution, hydrogen ions are maximum. In basic solution, the percentage of the hydrogen ion is minimum when we are comparing with the acidic solutions. Okay, let's see the next question. Under what soil condition do you think a farmer would treat the soil of his field with quicklime calcium oxide CaO quicklime? So this is the chemical formula of quicklime: calcium hydroxide and calcium carbonate, calcium hydroxide CaOH twice, and next one is calcium carbonate CaCO3. Okay, if the soil is acidic and improper for cultivation, then to increase the basicity of soil, the farmer would be treat the soil with a quicklime or laked lime or chalk, so it will be increases the fertility of the soil. Okay, let's see the next question. What is the common name of the compound CaOCl2? CaOCl2. What is the common name for this compound? We already discussed in the previous slides. Now the common name of the compound of CaOCl2 is bleaching powder. Bleaching powder, it's the molecular formula or chemical formula of the bleaching powder. Okay, see the next question. The name of name the substance which on treatment with chlorine yield bleaching powder. Calcium hydroxide on treating with chlorine yields bleaching powder. So let's see the next question. Name the sodium compound which is used for softening hard waters. Washing soda is used for softening hard waters. So molecular formula or chemical formula of the washing soda is Na2CO3, Na2CO3 and 10 H2Os. So this is the chemical formula of washing soda. See the next question. What will happen if a solution of sodium hydrocarbonate is heated? Give the equation of the reaction involved. When a solution of sodium hydrocarbonate or sodium hydrogen carbonate is heated, sodium carbonate and water are formed with the evolution of carbon dioxide gas. Here we are having one example: sodium hydrogen carbonate. Sodium hydrogen carbonate, when it is heated, it will releases the sodium carbonate, that is Na2CO3, along with the water and carbon dioxide. Carbon dioxide gas will be get liberates. Okay, see the next question. Write an equation to show the reaction between plaster of Paris and water. Write the reaction between plaster of Paris and water. The chemical equation for the reaction of plaster of Paris and water can be represented as, the reaction is there here: calcium sulfate along with the 1/2 of water. When it is treated with 1/2 of water, it will forms a gypsum. The gypsum molecular formula or chemical formula of the gypsum is CaSO4, 2 times of the water compound. Okay, see the some more exercise questions. First one, a solution turns red litmus blue. Its pH is likely to be, option A is 1, option B is 4, option C is 5, the option D is 10. The correct answer is option 10. Option 10, that is option D. So base turns the red litmus paper to blue and acid turns blue litmus paper to red. Basic solution has a pH value more than 7. Since the solution turns red litmus to blue litmus, its pH value is likely to be more than 7 or 10. More than 7 means remaining all three values are less than 7. That's why we are considering the more than 7 value, that is 10. See the next second question. A solution react with an crushed eggshells to give a gas that turns lime water milky. The solution contains NaCl, next one HCl, LiCl, lithium chloride. First one is sodium chloride, hydrogen chloride, lithium chloride, potassium chloride. The solution containing hydrochloric acid, HCl, hydrogen chloride. Next one, see the third question. 10 ml of a solution of NaOH is found to be completely neutralizes by 8 ml of a given solution of HCl. If we take 20 ml of the same solution of NaOH, the amount of HCl solution, the same solution as before, required to neutralizes, it will be 4 ml, 8 ml, 12 ml and 16 ml. So 16 ml of the HCl solution will be required. See the next one. Which of the following type of the medicines is used for the treatment of indigestions? First one, antibiotics, analgesic. Next one, antacid. Third one, antiseptics. So antacids is used for the treatment of indigestion. So these are the best methods we are going to consider, the best methods for indigestion. Okay, see the next question, fifth one. Write word equations and then balance the equation for the reaction taking place. First one, diluted sulfuric acid reacts with the zinc granules. We already discussed this reaction. Second one, diluted hydrochloric acid reacts with the magnesium ribbon. Third one, diluted sulfuric acid react with the aluminum powder. And fourth one, dilute hydrochloric acid react with the iron filings. So first reaction is there here. H2SO4 sulfuric acid react with the zinc, it form a zinc sulfate along with the hydrogen will be get liberated. Second one, when HCl react with the magnesium, hydrochloric acid plus magnesium, it produces the magnesium chloride and hydrogen. And third one is sulfuric acid along with the ammonium. When sulfuric acid is treated with the aluminum sulfates and hydrogen gas are the main two compounds we are obtaining from the addition of sulfuric acids and aluminum. Okay, next one, the last question. When HCl is treated with the iron, what it shows? Ferric chloride and hydrogen. So ferrichloride chemical formula is FeCl3, 2FeCl3, and hydrogen gas will be get liberated. Next one, sixth question, compound. So this is the sixth question of last exercise. Okay, compounds such as alcohol and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove it. Two nails are fitted on cork and kept in 100 ml of beaker. The nails are then connected to the two terminals of 6-volt battery through a bulb and switch. Some of the diluted HCl is poured in beaker and the current is switched on. The same experiment is performed with the glucose solution and alcohol solution. So what we need to observe here, it will be observed that bulb glows in HCl solution and does not glow in glucose solution. Next one, see the result of the experiment. HCl dissociates into hydrogen and chlorine ions. These ions conduct electricity in the solution, resulting in an glowing of the bulb. On the other hand, the glucose solution does not dissociate into ions, therefore it does not conduct electricity. So final conclusion of the reaction or process is, from this activity it can be concluded that all acids containing hydrogen but not all compounds containing hydrogen are acids. That is why though alcohol and glucose contains hydrogen, they are not categorized as acids. Okay, see the next question, why does distilled water not conduct electricity whereas rainwater does? And answer is, distilled water is a poor form of water and is devoid of any ionic species, therefore it does not conduct electricity. Rainwater, being impure form of the water, contains many ionic species such as acids, therefore it conduct electricity. Next one, why do acid not show acidic behavior in the absence of water? Acids do not show acid behavior in the absence of water because the dissociation of hydrogen ions from an acid occurs in the presence of water only. It is the hydrogen gas that are responsible for acidic solution. Let's see the next question. 5 solutions A, B, C, D and E, when tested with the universal indicator shown pH is 4, 1, 11, 7 and 9 respectively. Which solution is neutral, strongly alkali, strongly acidic, weakly alkali? So arrange the pH increase order of the hydrogen ion concentration. When we are arranging these given substances, we can easily identify whether the solution is acidic or basic or neutral. Neutral solutions neutral solution is D with a pH value 7. Strongly alkaline is a solution C with a pH value 11. And next one, strongly acidic solution, and solution B is the best example for that, and its pH value is 1. And next one, weakly acidic solution, weakly acidic solution or weak acidic solution. Solution A with a weak acidic solution because its pH value is 4. Weakly alkali solution. So weakly alkali solution is the substance which is having the pH value 9. The pH value can be arranged in the increasing order of the concentration of hydrogen ions as 11 is greater than 9, 9 is greater than 7, 7 is greater than 4, 4 is greater than 1. Okay, see the next question. Equal lengths of magnesium ribbon are taken in a test tube A and B. Hydrochloric acid HCl is added to test tube A while acetic acids is added to the test tube B. In which test tube fizzing occurs more vigorously and why? The fizzing will be occur strongly in test tubes A, in which hydrochloric acid HCl is added. This is because HCl is strong acid than acetic acid CH3COOH, and therefore produced hydrogen gas at the faster speed, due to which fizzing occurs. See the next question. Fresh milk has a pH of 6. Why do you think the pH will be changed as it turns into curd? So answer is the pH of milk is 6. As it changes curd, the pH value will be reduces because of curd is acidic in nature. Therefore, the acids present in the decrease of pH. Next one, see the next question. A milkman add very small amount of baking soda for fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkali? Why does this milk takes a long time to set as curd? The maximum shift The milkman shifted the pH of the fresh milk from 6 to slightly alkali because in the alkali condition milk does not set as a curd easily. For second one, since this milk is slightly base than usual milk, acids produces to set the curd are neutralized by the base. Therefore, it takes a longer time for the curd set. See the next one, 13th question. Plaster of Paris should be stored in moisture rope containers. Explain why. The antacid neutralizes the excess of acids and thus gives the relief from indigestion. When magnesium hydroxide is treated with HCl, it forms a magnesium chloride along with the water. Next one, see the 14th question of the exercise question. What is the neutralization reaction? Give two examples. Neutralization reaction means a reaction in which acid and base react with each other to give salt and water is called neutralization reaction. In this reaction, energy is evolved in the form of heat. So first example is when sodium hydroxide treated with HCl, it forms a sodium chloride along with the water. During the indigestion caused due to the production of excess of the hydrochloric acid in the stomach, we administer an antacid, generally milk of magnesium hydroxide, which is basic in nature. The antacid neutralizes the excess of the acids and thus gives relief from indigestion. So one more equation we are having here: when magnesium hydroxide is treated with the HCl, it forms a magnesium chloride along with the water. See the next question. Read this question first. Give two important uses of washing soda and baking soda. The two important uses of washing soda and baking soda. First one, washing soda. It is used in the glass. It is used in the manufacturing of glass, soaps, papers, and industries. It is used to remove the permanent hardness of the water. So these are the two most important points of washing soda. Next one, baking soda. It is used as a baking powder. Baking powder is a mixture of baking soda and mild acidic known as a tartaric acid. When it is heated or mixed in water, it increases carbon dioxide that makes bread or cake fluffy. And second question is, B1 is it is used in the soda acid fire extinguishers. So in the previous class only we already discussed the uses and preparations of the washing soda, bleaching powder, and next one sodium hydroxide, sodium chloride, POP. Okay, just go through it. You will get some more ideas about the uses and properties of these kind of the compounds. So these are the some of the exercise questions from your text tube. Okay, in the next class we will discuss the next chapter of your chemistry part. Till then, be happy, have a nice day. Thank you.